Good afternoon, everybody. Hope you all are awake after the lunch. And welcome to my talk. I will be talking about starting with Java development in Microsoft Azure. And I'll give you some tips, some tricks, and well, perhaps some knowledge so then you can start to deploy your applications on the cloud. So, well, the agenda for today is the following. We're going to have a short introduction. We're going to talk a bit about the cloud, how we've been deploying applications on the cloud so far. I'm going to name a few Azure services that we're going to deploy Azure apps. Also, we're going to talk about debugging and the monitoring, of course. But, well, who am I? Why I'm here? This is me, with my dog on the picture, with my long name, because I'm Brazilian, and Brazilians, they love to put long names on people. I work as a backend chapter lead at ABN AMRO, while building amazing capabilities for internet banking, and I live in Netherlands for quite a while. Don't speak Dutch, because yeah, it's too hard. Yeah, love to be outdoors with my dogs. That unfortunately I didn't put a picture of the other one there, but I have to. So, and that's about me. Well, before the whole talk, there's a meme that probably if you're a Java developer at a certain point, you had a manager that asked you to deploy your AGB to the cloud, right? And then you were, yeah, and now what? What do I do? Does it run Java 6 on the Microsoft Azure or AWS? Perhaps it does. But I'm going to spend some time to make it work. And why this talk? So part of my work is to recruit people, and then sometimes I realize that we do not see Java developers going to the cloud. And 2023, like pretty much any big company or small companies, they start all the business on the cloud. So somehow it became a basic knowledge for everybody. So my goal for today is to help you, if you didn't work with cloud yet, to start. And the Microsoft Azure was the provider that I chose because I work with that and I'm big enthusiastic. But I will not try to sell the Microsoft product because I don't have any commission. So let's go back in time a bit. How we used to deploy the Java apps. So I see like a different range of ages here, and so perhaps a lot of people will recognize or relate a bit. We start on the, at least this slide, on the 1990s, where you would deploy GSF applications, servlets, jar files, and web servers like WebLogic. So I assume most of you saw that already, and experienced, had some headaches, and you're glad that you're not there anymore. And well, middle 2000s, we start with lightweight frameworks like Spring, for instance, Strut 2, that became a nightmare for a lot of people. Yeah, things start to evolve a bit. We start to use like WAR and our files to deploy servers like WebLogic, JBoss, Whitefly, you name it. There are a lot of them. And then we got to the era of Java 6 and 7, right? Like it was a big improvement back then. So it's you could see like more applications running light memory compared to the previous ones because Java used to suck and then start to be a bit better there. We have like good APIs. And yeah, but you're still using like the servers like WebLogic and yeah, Tomcat, Whitefly. And well, then we start with the rise of DevOps, let's put it this way. So the companies start to adopt DevOps practice, containers, yeah. So things start to get a bit faster on the Java world. You start to see like you can automate your builds, you can automate your tests, and but again, you still deploy in the same way, but you already had like the Spring Boot embedded Tomcats, Jetties, or Undertow. So you could deploy it as a standard jar file. Well, and then you have that, of course. I was a bit ahead. So, and as we had the rise of containers back then, if someone worked with containers in the early in the days, you know how messy it was to deploy something with containers in production. So yeah, I ended up in a project using Swarm to manage some containers, and I realized that it was one of the terrible mistakes in my life. But, well, the choice was made. We need to live with that. So, but luckily, we had Kubernetes. And so Kubernetes started to become a very popular tool. A lot of companies adopting, even though you did have cloud providers, but not as popular as they are nowadays. But you could bring your application to the cloud. And here we are today. So adoption of serverless, serverless is growing a lot. More and more of the DevOps and CI/CD and all these buzzwords that everybody's tired of hearing. But for me, like one of the main motivations for this talk is like Java is getting better and faster. And well, as a previous slide, Java announced like in 2019 that there will be a version every 6 months. So it was a bit different. Like nowadays, we have JavaScript that they have a version every week, or a framework release a new week. And for the Java world, it was a bit different. So we need to wait a lot. And of course, especially when you're in a large corporation, you don't want to keep updating your software. But somehow, we are there now. We need to update things very quick. So if you work with Spring Boot, for instance, you have a CVE every other week that you need to upgrade it. And that became more live. So I'm glad that Java is getting better and faster, so we can go full to the cloud. And well, and about Microsoft Azure, I was new to Microsoft Azure a while back, and I would say new for the Windows world. So I didn't even know it was possible to use Java there. So I found out that you can, and it's very good. That's why I'm here presenting that to you. But Microsoft is a well-known brand. Microsoft Azure is competing with AWS nowadays, especially for large corporations, due to like countless integrations with all the services that we already use. Well, for this presentation, I prepared a little demo. I will show a piece of this code here as well, but later on, well, you can download these slides, and then perhaps you can play around. So it's like a gift for you, or not. So, well, for that presentation, you're going to need a few tools. I listed there, but I didn't explain how to install, because nowadays we have ChatGPT, so you just ask them, and then they tell you how to do a modern IDE, Azure CLI, npm functions to run Azure functions, but there are other methods as well. This one is the one that Microsoft recommends in their recommendation. GraalVM if you want to deploy cloud-native applications there as well. And Docker, of course. So I have all installed. What do I do now? So I think you might think that when you download the code. And first, before I start to show the code, show the projects running, I will list the service that we're going to talk today a bit about Kubernetes, AKS, Spring Apps, containers, VMs, and the tool that we are going to demo that's on the code. So as you can see, like if you look at that pyramid of platform as a service, infrastructure as a service, service as a service. Oh, wait, well, I got confused now. But Microsoft cover all of them. So you can well choose the service according to your problem. So if you have an infra guy in your team or infra girl, well then you can download Kubernetes, install there, and AKS is a great tool for that. But sometimes you just want to deliver Java code and get the business up and running. So perhaps serverless is your thing, Azure Functions. So it depends. You need to choose according to your requirements. And I will try to show at least two that are that you can focus on the code and not that much on infra. But starting with AKS, right? Like, how many of you know Kubernetes or work on Kubernetes? A lot of you. Have you need to update something on Kubernetes, like any version, patch? Yeah, you know how normal it is. So, what is the main thing of Kubernetes on Azure? It's managed Kubernetes, so the security updates, security patches, it is done all by Microsoft. You just use their instance. So you can decide how you use that, have perhaps one control plane there, and then initiate your cluster somewhere else. So it's quite easy to do that. So I would say, like, if you like to try things at home, and then you try to install a Kubernetes cluster and then configure all these control plane and servers, and it's quite a hustle. And with AWS, with Azure, I'm sorry again, it's quite easy. So also very well integrated with in the whole enterprise ecosystem. So if you have, for instance, Azure Active Directory, you can use the authorizations that you have there and integrate your application, and make it work in your corporate quite easy. But we're not going to focus that much on it because, well, it's a Kubernetes. You can run in any cloud. It's all the same. So in the end, you need a Java app running there. But this one is a bit more interesting for this group, I would say. It's Azure Spring Apps. Azure Spring Apps is, I made a nice analogy with a picture of my dogs playing underwater. It's a home-trained pet, right? Like all the fun on the mess. It's not actually true with the dogs because they make a lot of mess. But Azure Spring Apps run on top of Kubernetes. So you have most of the Kubernetes capabilities there, with one big difference is that you don't have to deal with the Kubernetes pain. So it's a managed environment. So as you can see there is a picture that I took from the Microsoft page. If you work with microservice environment, you needed to deploy a cloud, how can I say, Spring Cloud Gateway or Service Discover, Eureka, all those things. And again, a lot of pain. You can, and with Azure Spring Apps, you can deploy all of that just as a simple Java app that will run on top of Kubernetes. So no hassle, just configuration, and what it brings to you. Things like, well, distributed tracing, for instance. We're going to look into the Azure Monitor and Azure Application Insights. You can combine that with the Kubernetes and a very fun feature like a blue-green deployment. So, well, all the Azure apps, they have like this building capability that you can do a blue-green deployment, just choosing the right slot, put it to run, choose the target, and then some users will see it, others will not. And if you can do that in a scale of application that runs on top of Kubernetes, so you have like your 10, 12, 20 microservices running, and it makes your life way easier, so then you can focus on what actually matters, that is the business capability, instead of well, more infrastructure stuff. I did not create code for that because, well, there is a very good one already on the Microsoft website. I left the link there that you can deploy the Pet Clinic project with Spring Boot, Spring Cloud, Service Discovery, the whole infrastructure, so you can, have fun there. So the link is there. And just a little warning, be careful, it's not cheap. That fits for all cloud providers, right? Like, so you need to be careful because you can choose the wrong price and use the enterprise tier, which will cost you a few bucks per hour. And it's not fun. And all of them require a credit card, so you cannot escape from it. So just mind. And I will give you some tips as well how to use infrastructure as code to at least help you to build things, stop it, and continue when you start to build again. So then you don't need to recreate your infrastructure every time that you start to study, for instance. Well, and another service is the container apps. I would say that it's a higher level of those two. So you have like the platform Kubernetes, and then you have Spring Apps on top of that. And the containers is more when you need to run like a single instance. And with that, you can, for instance, run a key clock if you want to build a authentication server there. Or even your Java application in a Docker image. Well, VMs, there's nothing special to talk about VMs, but I would like to mention because when we talk about Java, especially in large corporations, you talk about legacy. You talk about things that cannot go to cloud, and sometimes you have to because you're decommissioning the old cloud provider that provides you VMs. So the option is there as well. So So now let's talk about the app service. That's the fun part, because that's the one that we're going to demo code, and then I will show you a bit in practice how to use that. I put a screenshot from the pricing, the schema that you have the prices and the CPU and the memory. So to start with the app service, you're going to need the app service plan. App service plan is the equivalent of a server farm, which is your cluster farms that you used to see back in the days. Basically, the computer that will run that, well, the set of computers. You can define one or more app service inside of service plan. So it means that when I create a service plan using the P5, for instance, 32 CPUs, 256 of memory, it's quite powerful for a Java app, right? So you might not need all of that. So you can deploy more app service there as well. So there are a lot of techniques to how to organize your cloud environment, and you can always use that and perhaps group it by types. I don't know. You can be creative on that. And and the app service, one of the main things of it is it supports a lot of language out of the box. So you can deploy Go, Rust, Node.js, C#, and Java, of course. You can set up multiple environments, or how can I say, slots. So then you can use the blue-green, for instance, and it's production ready. So all the patches are there already. So you just need to define it properly, and then you're ready to go to production. Well, talking about Java there, we have 3 options at the moment. So Microsoft built their own version of Java there with using OpenJDK. So we have the versions 8, 11, and 17. So 17 took a while to get there. So I'm hoping that with 21 will be a bit faster. So we can move to 21 and enjoy the virtual threads very soon there. And well, I would start demoing here, but then I realized, well, I'm going to show some infrastructure as code, and then I need to talk about Bicep as well. So how many of you know infrastructure as code or use that in your day? It's quite a number. Yeah. And how many of you know Bicep? Terraform? Well, I'm surprised that there are more people who know Bicep than Terraform. That's new. So I will show you a bit the structure of Bicep and how we can use that to provision app services there. So first, so for this demo, I create this small project here. There is a file. Oh, I think that's the wrong screen. It should be mirrored. Sorry. I think now you should be able to see Visual Code, right? Yes, I'm sorry, because when PowerPoint was, I mirrored the screen, but PowerPoint took over, so then I could only see here. So I hope you all can see it. So that's a basic Bicep file. I'm not going to talk about the types in Bicep, the semantic of it, but Bicep is a DSL written by Microsoft that manages ARM resource better. ARM resource was how you used to create resource on Azure. So. But it was quite verbose, based on JSON, and well, quite difficult to build the whole thing. So they built this language, this DSL, where you can easily build modules, and then when it compiles, it will create the ARM file, the JSON file, so then you can call the Azure API using the Azure CLI to deploy it. And so a few things that you can see here in this code. Well, I mentioned that I'm going to deploy an app service there. So you need an app service plan. So of course, this is a demo application. You have like very minimal configuration here. But well, that's the app service plan. We have like the name, the location, a few properties, and the SQ. And as you can see here, I could define those things in a variable up there, and yeah, and then use these variables here. So if you want to create like some name conventions or even automate the entire creation of your infrastructure, you can explore these. And one thing that I particularly like about using infrastructure as code in a language like this, you can also do it with Terraform, for instance. It's very similar. You can create like subfolders and modules for that. So then, for instance, like in this case, I need one service plan, but I also need one app service and one application inside. And later on, I will also want to deploy another one, right? Like, so another service plan, another app service and application insights. I could just repeat the code and yeah, and then put all in one file, and then this file will grow very much. And eventually, it's difficult to maintain. It's difficult to refactor. So the language provides you capability that where you can, for instance, create a file called application insights and call it a module. So you see here I have resource, it's an application insights. I have some parameters that I need to send. And then when I go here to my main file, I do have the reference to my module. So I do have here application inside humans, just a context of this application. This application is a HR application, so one service called humans, the other called onboarding, and the other is called parking. So it's a sort of you enter a company and they need to create your onboard system and your parking. So in this case here, I needed 3 application insights. So I can easily just refer to my module there and send the proper parameters, and then I will create application insights. So that's Bicep. Well, let me go back. And now I'm going to show you the applications, the app service in practice. So if I go there to my application service, here I have like my Azure account. I hope you all can see it well. So here I have my humans app working. It's up and running, so you can see here that it was deployed by code. It was deployed manually. I will show you how in a few seconds. You can see also the Java version. And you have all the configurations of the app here. So for instance, if you need to send I don't know, some JVM options, you can also use it here. Of course, it's I always recommend to do those things via pipeline and or via infrastructure as code, because eventually you're going to need to replicate that in a second environment, and it's never fun when you need to like remember everything that you did, or even worse, document it. So it's better to write the documentation as infrastructure as code. So I made an application that should fail intentionally, but then you can at least see some errors there. So for instance, I made a request here, and why this application will fail. It's like one app service that calls 2 functions, and well, we're going to go to functions as well. I will show you why the functions are not working. But for my sadness, it did work. So yeah, I wish it would fail. But this service, when you create a new person there, like Rafael, and then the license plate, it fetched me like a new buddy, Anakin Skywalker, and a parking spot from 2 different services. So this example, it's on the code that I share here, so then you can play around yourself. And if you go to Azure there, you can see, for instance, well, not here. Yeah, you can see already quick dashboards here on the app service without the application insights that we're going to cover later. Yeah, that's about the app service. I will show a bit more later, but let's go back to the slide. Well, now I would like to talk about Azure Functions. How many of you know Serverless or are working with Serverless? Nice. Well, if you don't know Serverless yet, it's focused on the code. So basically, you don't have a server that is running up from 7. So it's a company managing that for you. Let's put it this way. So Microsoft decide when your containers go up or down, and event-driven. So you can use that combined with, for instance, upload a new file to a storage file and trigger a file, trigger of Azure Functions. And so with this kind of technology, you can focus on the business entirely and save some money as well. It depends on the use case, of course. And of course, if you read this article, you might be thinking, oh, that's BS, but because, AWS changed their architecture and then they start to use a monolith instead of serverless. Well, you need to read the article to understand it better. But serverless is growing very fast, and there is a good reason for that. Like, there are good technology that you can use, and then you can save a lot of money and then focus very much on the business, on the user, instead of focusing on the infrastructure. And there are a lot of frameworks that you can use that. I just put a picture of a few that I never work with this one, by the way, and Micronaut as well, so I have no idea, but the others, yeah. So pretty good. They all have their own good and bad things, so you explore that and create your own conclusions. So to run serverless locally, or in the end, serverless will be a small function, but you need to simulate that. And for Azure Functions specifically, you have this npm package, so you might need to install npm in your laptop, and then you can run it with just Maven tasks. Well, when we're talking about serverless in the cloud, you have to, well, you have a lot of things to take into account, but those two is very important, at least to start with. What is a cold start and warm start? So basically, I say that we don't have a server there, right? So, and how does it work? How does our function get called if we don't have a server? The cold start is the time that if you call the function for the very first time, it will spin up your container, spin up your function, and then it will call it. So it will take a few time. And warm start is the subsequential call. So you just call the function for the very first time, and then the second time is way faster. And why I mention that? Because we're working with Java. And JVM is not that light. Well, so it's something that we need to take into account when we are working with serverless and Java. Perhaps it's not even the most recommended technology at the moment, but the frameworks are evolving quite quick. So I'm pretty sure that it will pick up. And the thing that I like about Java, the warm start is very good. So if you compare with other language, for instance, it's way faster. On the other hand, the cold start is slower. So it depends a lot of your business requirement. If you're going to build a function that you're going to call once a day, perhaps you're going to think about using other language, not Java. But, or you have like some batch processing, for instance. Yeah, it could be a very good use case. Because then you can use the best of both worlds. You start the container once, and then you process everything that you can. Server is down. You can wait for the next day and do it again. So, of course, it depends a lot. But, well, the focus of this talk is not serverless, so you can experiment a bit at home. And there's like this last bullet here. Frameworks like Quarkus and GraalVM are making that better. They are evolving very fast. And very exciting to see. GraalVM just released a new version. I heard like very good numbers there. And well, I have an older version here, so they will also deploy application with that. And well, now I'm going to show you what a function looks like in Java. And but before, how many of you know Quarkus and Spring? So more Spring, of course. So let's do Spring, and because I built both, then I will show a few things that you need to add. So for instance, this one, I have 3 services running here in my IntelliJ. This one is a Spring Boot app. Very simple service. You make a post call, and can I hope you can see it, or it's too small. Okay, now it's better. So it's a very simple function, as I mentioned. You make a post call, and then you get a number. If you remember, back in the example on the Postman, I had like a register person, and then I gave a name, a license plate, and then I got a buddy and a parking spot. So this one is providing parking spot. And it's very straightforward, right? Like it's a post, and then, yeah, it has like some JSON configuration. And a record. I tried to write as little code as I could. And you're going to see here a few dependencies that you're going to need that, like the Azure Functions library. The Quarkus. And here, you're going to see some configurations. That's one way of doing that. You can do that in multiple ways as well. So if you prefer, for instance, to create that in a, I don't know, config map, for instance, if you're working with Kubernetes, and then later on you can just fetch that instead of hard coding this information from the POM. So you can see there I have a function app name, and then I have the region, and I have the resource group. It depends, right? Like some people really don't like to put this kind of information there. In this case, for a demo, it's just fine. And how you see that on the Azure portal. So if I go there, I have my parking app, and I have functions. So you see here, I didn't even bother to rename it. I just downloaded the example from Quarkus and well, change it to deploy there. So don't expect a lot of it. And it's quite straightforward. You can also test here if you feel like, but you can also test locally. So they are all public here, and I didn't create any kind of security because I intend to just drop my entire resource group when I finish this presentation. So then that's why I didn't bother hiding the IDs or things like that. So as you can see here, well, I sent a request, I got a response, and that's my function running with native compiler. So I'm using I'm using raw VM for this one. I even place a command here, so then if you feel like building it, where is it? You can just do it. I'm not going to wait for that because it's going to take a few time. But this command will, well, it's a Maven task. It will package that using the native compiler, and it will deploy that to Azure. Very, very straightforward. On the other hand, the Spring Boot app, if you go here, onboarding. So you have a bit more code with Spring. Because if you look at Quarkus, for instance, you're going to see that we have one file, and then actually two, because I have a record here with the user registration. But yeah, it's quite decent, because for a function, I expect to have as little boilerplate code as possible. With Spring's still catching up. They also can, this one is not using native, but you can already use native for Spring as well. So you can build faster functions. You still need the Spring Boot application here, and that's how you create a function using Spring Boot. So you have a few more configurations, like request here is a bit different, but in the end, they are all the same. And if I show you here, that's the onboarding. You can see some data there. Yeah, that's my function. That was called process resume because I was building another kind of example, and I didn't rename it. But yeah, so they are very similar, and I will show you as well the code that provisioned that infrastructure for it. So if you go there to the bicep code, I do have two functions here. as you can see, I did the same idea, the same approach of the application insights. I create a module called function that has like most of the configuration, and then I just send the information that is actually needed for this. So what do I need? I need a name, the instrumentation keys to connect the application insights, so then I can send all my logs to the application insights feature. Location and the service plan ID. As I mentioned in the beginning, I can add like one or more elements for the app service plan. So then I'm sharing the hardware with the app service, for instance. And the storage account, because strangely, when you use events, and then you need to somehow trigger the events to go to the function. So my event is HP. So I use the storage account, and then it goes webhook of the storage account HP events, and then it ends up here. So for app service, for Azure Functions, you're also going to need the storage account. And as you can see on the code here as well. Yeah. So let me go back to these slides. Well, we saw app service running. So if you have an application that runs 24/7, app service is your resource to go. We saw functions, and we need to monitor all of that. So monitoring is quite an important part of our jobs. And one thing that makes me enthusiastic about Azure is that I can use all inside one platform. There are better platforms, I think, that can do monitoring. But, well, they're not integrated. So you can, if you're working on the cloud, I prefer to keep all on the same environment and have less hustle with infrastructure. And so we have the Azure Monitor that is like the parent, I would say, like where you can see when you have like multiple applications, and then you can track the end-to-end transaction, all the tracing that you have there. And but what we're gonna focus here is the application insights, because that's the one that will monitor your application specifically. So it's based on open telemetry. So any application that applies that can get the data there, and then can have the dashboards and the metrics. So all built in. And so you're going to see all the dashboards. And Microsoft also implement a very interesting feature called smart detection. So basically, well, the AI doing things again. So it sees a few strange behavior for application, a few 500s or 403 that should not be there. It will automatically create a metric for you, or perhaps even a trigger for an alarm. So then you can see that your application is failing, and then be notified when you have that 500, or perhaps fix it. But yeah, it's quite interesting to see a platform acting like that. And I'm using that on a daily basis, and then every time that you have something that is not well tested, and then you have a new smart metric popping up, because, well, it will break. And we go for the demo again, because this one is better if I show. So, well, as I mentioned, I create one application inside for each. So this one is for my app service, the one that is running 24/7. And as you can see here, I already have like some failed requests. You can have the service response time. Like, you have very interesting charts out of the box. You don't need to create these dashboards. And one thing that is very interesting on that, you can search for transactions. So if you have like some specific exceptions that you would like to search for, you can find all of them here, and together with the request calls as well. So then you have like a end-to-end, and also supports the MDC context. So if you want like to have the distributed tracing, you can enable that as well. You see on the functions, perhaps. Let me show you there. If I group by type. It's the same. So same application. Oh, there's an application map that I can show you from the other one, from the. So as you can see here, I didn't set up any of these, but just because I make a call from service A to service B, it already built my application chart. So it sees the instance of app service here. It sees the 2 calls, the average request time. So you see it was very long because it was 1 request when the container was not up. So it needed to spin up, and then it took some time. I was hoping that would take 10 seconds, but it took only 3, unfortunately. Yeah, and then it built it all automatically. So it helps you to identify when you have like a missing call or something like that. And well, one last thing that I would like to show you. So this is all very basic, right? Like you can see a few data, so perhaps any other platform can do that. But sometimes you have like a very strange issues, right? That you need to debug, for instance, on the memory level. It allows you to use the performance tools here, and then you can export, you can profile your application. So using the profiler. And I will not do that here because it's going to take a while, but it will analyze your JVM, and then it will create the JavaFly record file. So then you can easily check and analyze your JVM. So yeah, I will not go into details here, but it allows you to do this kind of things as well if you have like very serious memory issues, for instance. And let me go back to here. That was it. Thank you. I hope you got at least a bit excited to deploy your applications to the cloud. And if you want to stay in touch, I don't post anything on social network besides like my dogs and food. But yeah.